All right, still in domain number 3, security engineering. We're going to talk about information systems security evaluation models in this section here. And specifically, when we want to implement security within our enterprise, we want to have a framework for implementing security within that enterprise, having specific policy documents that identify the requirements for the organization, the specifications for describing the rules for implementation that would allow us to enforce the security principles that we're trying to define. So a formal security model, and we'll look at various ones throughout this section here, are going to describe and verify our ability to enforce security policies in mathematical or at least calculable terms, right? And that's kind of the point of having any kind of structured approach or structured model. So the security policy that we define is the what. What are the requirements for the security that we're implementing? And the security model is the how. How are those requirements translated into implementable and auditable technical specifications given the demands of whatever that policy might be? So models let us focus on system-level security architecture, but almost down to the component level. So let's take a look at some of these different models. We're going to start with evaluation criteria, and there are, evaluation criteria. There are kind of different models that exist. What we call the TCSCC model, the Trusted Computer Systems Evaluation Criteria model, common criteria. There are others as well, like the ITSEC model, Information Technology Security Evaluation Criteria model, and so on. And we're going to take a look at these, really kind of focus on these three models in this particular section. But these formal security models give us a way of evaluating system components that are going to be incorporated into our system design, ensuring that we are implementing not only the features that are required, but keeping security in mind, especially with these more complex systems that are being integrated. We also have mechanisms that provide us the ability to review and verify the implementation of the secure design based on real-world vendor products that are being developed. And we'll see actually how these models can be applied, or these, I would actually not even say that these are necessarily models. I would say these are more evaluation techniques or evaluation methods. The names themselves kind of imply that they are specific evaluation methods for evaluating systems functionality to make sure that they meet specific requirements. But the idea is that we're applying this evaluation criteria to make sure that the system meets the security goals. And as with any kind of framework, it is a kind of a developed and trusted methodology for describing, specifically in this case, security requirements, making sure that those security requirements are being consistently applied. We evaluate the products against those requirements, which results in reported results or provides reported results, and then we can use those results to identify whether or not the system meets the demands of what it is that we're trying to accomplish. All right, and that is essentially what we're going to be looking at with these three models. The evaluation criteria gets published over the years to verify systems to enforce the security goals, and then it also allows us to do third-party evaluation based on evaluation labs, looking at vendors' products, assessing those products against security requirements, publishing their findings, so that if I want to buy an off-the-shelf product or I want to integrate an off-the-shelf product into my system, I don't have to reevaluate the security of that system or its functionality. I can look at the the criteria that were used to evaluate that was used by this third party to evaluate that system, and I can decide whether or not that is going to be adequate for the integration of those systems into my environment. So we're going to look at 3 evaluation criteria methodologies in this section here: TCSEC, the Trusted Computer Systems Evaluation Criteria; ITSEC, and finally, Common Criteria. All right. So let's get started here. Let's start by talking about what certification and accreditation is in general. As the names imply, right, certification is a way for us to test and verify that a particular system meets its documented requirements, namely security requirements. That's what we're talking about in this particular context. And we evaluate that system in the context of its functionality, right? How does it interact with the systems around it? Is it operating based on its intended use? And how it's connected to the network or connected to other resources. We're going to test the hardware, the software, the configuration in a production-like environment, simulating hopefully what the real-world scenario might look like. The results of that test, how it's implemented, how it's integrated, etc., will become our baseline, and that would be what we use to test against a set of security requirements. A positive certification means that we can then move into the next phase of integration or the next phase of implementation. The accreditation phase is where we evaluate the capacity of the system to meet organizational needs. If the needs of the system satisfy organizational requirements, we accept the evaluated system for a period of time. Remember, this is an iterative process. We don't simply do it one time. Conditions of the environment will change over time. Integration to other systems, upgrades to other systems, etc., will happen over time. So we need to make sure that we continually evaluate those systems over a period of time. If configurations get changed or the accreditation window expires, we have to go through the whole process again of accrediting that system and certifying that particular system. All right, so let's start by talking about TCSEC, the Trusted Computer System Evaluation Criteria. It's called the Orange Book for a reason, because it, the TCSEC book is actually literally orange, but it is a set of evaluation criteria that was developed by the United States government, specifically the Department of Defense, that sets the basic requirements for assessing the effectiveness of computer security controls that are built into computer systems that are being established in within the confines of the Department of Defense. It was a publication that was used to evaluate, to classify different computer systems for processing, for storage, for retrieval of sensitive information or classified information. It was part of the Rainbow series of publications. I think they were kind of initially released in the early 80s, like around 1983, I believe, by the National Computer Security Center, which was a spin-off of the National Security Agency, updated in 1985. So the Orange Book, DoD 52 or DoD Directive 5200, was later replaced. The original one, I think, came out in 2002. That was replaced later on by 8500 and then version 1 and version 2, I think, around in 2014 or 2015. But what did TCSEC state, right? Under policy, the security policy has to be explicit. It has to be well defined, and it has to be enforced by the security system. There were 3 basic security policies that were specified in TCSEC. There was a mandatory security policy, which allowed us to enforce access control rules that were based directly on the person's clearance if they were accessing that system, how we were specifying authorization for the information, and how we applied different confidentiality levels of the information that was being accessed, right? There were other factors that affected this. Some factors included like physical and environmental factors, but the policy had to accurately also reflect components of general policies that we were applying within our organization, other guidance principles, laws, and so on. There's also a marking component to this. The systems had to be designed to enforce a security policy, but we had to be able to store and preserve the labels for data and retain the labels if data was being exported. Why is marking such a big concern? Well, in order for us to effectively apply controls, we would have to mark the data. And we're talking about literally classifying the data, having either electronic or physical markings on the data to indicate its classification level and how we would apply security to that particular piece of data, or that system, or that computing system, whatever it might be. Then there was a discretionary component, right? Whenever it comes to security, we always kind of have these kind of categories. We talk about DAC, discretionary access control, MAC, mandatory access control, marking, classification, etc. when it comes to securing information. A discretionary policy allowed us to set up rules for limiting access based on individuals need to know, right? Need to know that information. But the term discretionary indicates that this is not something that necessarily would have to be enforced. Now, we would identify individuals that may need access to information, but then as the user, you would be able to determine whether or not, or the system or whatever it might be, you would be able to determine whether or not that was something that you would access or whatnot, as opposed to a mandatory security policy where that's strictly enforced. All right. Accountability, always going to be a component of any system, right? Accountability for policies have to be enforced. We have to be able to be sure that we're able to identify individual users with an identification component, authenticate those users, and keep in mind, there is a specific difference between identification and authentication. I talked about this in one of the previous domains. Identification is just a statement or an assumption of who you are based on a presentation of a very basic set of credentials, whereas authentication is the verification of who you are, right? And that would be, something that we would do through various mechanisms of control. Auditing, being able to identify the actions that might affect security, and then being able to associate those particular actions to a specific individual. That might also be considered some sort of accounting function, an accounting function as well. All right. Assurance. The computer system must contain hardware or software mechanisms that can be evaluated to provide us a level of assurance and trust, essentially, that the system is doing what it's supposed to do. And we can accomplish assurance through the use of operational mechanisms, by looking at integrity. We can do covert channel analysis. We'll talk about covert channels a little bit later on. Looking at trusted facilities management, trusted recovery, systems architectures, and so on. Oops, sorry about that. We also have lifecycle assurance, which also includes security testing, design specifications and verification, configuration management, trusted systems distribution, and so on. And then continuous protection assurance, the trusted mechanism that enforce the basic requirements have to be continually protected against tampering and unauthorized changes, meaning that the mechanisms that we put into place on the platform or within the system have to be tamper-proof. We have to be able to trust that those mechanisms are protected. Because if we can't trust the mechanism, then we can't trust the system. Within each of these classes, of course, there's always going to be some sort of documentation component. Different guidelines, different manuals, test documentation, design documentation, and so on. Now, TCSEC defines 4 divisions of protection. This is the part that might be you might see on the exam. Divisions are D, C, B, and A. A is going to provide the highest level of assurance for protection, and D is going to provide the lowest level of assurance. Each division that we see here kind of represents a difference in the trust that the organization can place on whatever system was evaluated. Now, keep in mind that we are talking about third parties going through and evaluating systems, off-the-shelf systems, or systems that are developed by other entities for the consumption of the federal government or government agencies in this particular case. Remember, this is a Department of Defense directive. So ultimately what's going to happen here is we're going to evaluate a system. It could be a firewall. It could be a proxy server. It could be a group of computing resources that work together to provide a function. This could be applied to anything, specifically and generally technology. I don't know that I've ever seen examples where this is applied to non-technological components, but where we evaluate the systems and we give them a grade based on these 4 divisions. We'll see on the next chart, on the next slide, what those divisions look like in more detail. All right. Divisions C, B, and A also have subdivision classes called C1, C2, B1, B2, and B3, and A1. And then each division and class gets expanded or gets modified to indicate the requirements immediately prior to that division or class. We'll see that on the next slide. So D, starting at the bottom, is our minimal protection. This is reserved for systems that have been evaluated, but they fail to meet the requirement for a higher division. So minimal protection. C is our discretionary protection. Okay, it's defined as discretionary protection, and we have 2 subdivisions which are called classes, C1 and C2. C1 is the discretionary security protection. That's going to include things like identification and authentication. How do we separate users and data? Discretionary access control components, DAC components, which allow us to enforce access limitations at a discretionary basis, on an individual basis. And this is required for, say, things like system documentation, user manuals, etc. And then C2, we have controlled access protection. This is the same with, it still applies the DAC concept, but it does it more granularly. There's individual accountability through individualized login procedures, why it's called the controlled access protection. We have audit trails, there's resource isolation, and so on. We move up to Class B, mandatory protection. B1 is called labeled security protection. This is how we label systems. What is our security policy model? What are the data sensitivity labels that we're going to apply? This is also where mandatory access control gets applied for particular components. What are our label exportation capabilities, and design specifications and verifications. B2 is structured protection. This is our security policy model, which is really just a scheme for specifying and enforcing specific security policies. We kind of talked about that briefly at the beginning of this domain. DAC and MAC enforcement get extended here as well. This is also where we look at covert storage channels. Let me define that. We've already seen that term a couple of times, covert channel. We will see it again later, but I'll give you just a brief description here. A covert channel is really just a type of attack that creates the capability to transfer information between systems or between applications or between processes that normally would not be allowed to communicate based on an established security policy. Covert operations kind of comes to mind when we think of this term. Okay. We also have carefully structured components. We have protection critical elements, non-protection critical elements. We also have a design and implementation component for testing and review here as well. I'm talking about B2, the structured protection. Authentication mechanisms get strengthened here. Trusted facility management is provided here. Strict configuration management controls get imposed here. Operational and administrator roles are defined and separated here as well. B3, security domains. Reference monitor requirements are specified here. A reference monitor defines really just a set of design requirements on reference validation mechanisms, which allows us to enforce access control policies that gives then those resources or those assets the ability to perform operations on the system itself. Structured code exclusion, significant systems engineering at this point as well. All of our security administrator roles are defined. That's why it's called the security domain. We have to be able to audit security-related events, automate components like intrusion detection, notification and response, trusted path for trusted channels to provide confidence that the user is communicating the way that they're intended to communicate, also ensuring that the channel is providing confidentiality and integrity so attackers can't intercept or modify the information that's being computed. That's or communicated, I should say. That's what a trusted path is. Covert timing channels as well, and other things. I can't recall all of the components, but and then verification protection at the very highest level. A1 is verified design. The functionality includes B3, but also adds formal design and verification techniques, formal management and distribution procedures, and so on. So it's B3, but it includes some additional design and verification elements. All right. Now we can go beyond A1, but we don't need to in this particular case. All right. This is kind of what I was talking about in the previous slide. I was kind of summarizing this. I went into a little bit more detail than what you see here, but for the most part, I think I've covered most of this. Let's see, D. Evaluated. The system was evaluated, but does not meet security requirements. Maybe, right? It certainly doesn't meet the security requirements at higher divisions. But we still may accept that system if it's a non-critical system. Like I said, C1 is discretionary security protection, which includes discretionary access control. C2 is controlled access protection. Improved DAC, right? What I would define as kind of more finely grained DAC, if you will. Individual accountability, resource isolation, auditing, etc. I don't need to go through all these again. I'm just kind of summarizing just to make sure I hit all the points, right? Mandatory access control at B1, including informal statements of the security policy model, data sensitivity labels. All discovered flaws must be removed or otherwise mitigated to classify a system at the B1 level. B2, structured protection, DAC and MAC enforcement, extended to all subjects. Security policy model clearly defined and is formally documented here. Covert storage channels are identified. Objects are carefully structured into protection critical and non-protection critical classes. I mentioned that specifically. I think I pretty much hit all of these points here. All right, B3, A1, and then finally beyond A1. I didn't really talk much about beyond A1. System architecture demonstrates that requirements of the self-protection and completeness for reference monitors are implemented in the trusted computing base. Well, you go through all of this and you say, okay, I understand the words, but what is the purpose, right? How is this being applied? And I want to circle back and kind of explain what this orange book or the TCSCC model was intended to do. You have to keep in mind, this was a Department of Defense concept, right? Department of Defense function, specifically, like I said, the part of the NSA, well, a component of the NSA, the National Computer Security Center. And the idea is that they wanted to develop a platform or a structure for evaluating systems that are being integrated into government agencies, and define what the basic set of requirements were to classify those systems to meet certain criteria. And that's why it's called the Trusted Computer Systems Evaluation Criteria. Think about the name, right? And the reason I'm mentioning this specifically is this is the kind of thing that you need to think about when you're taking the exam. Now, unfortunately, on the exam, they may only give you the acronym. They may only reference TCSCC. So it's a little difficult to identify what the function is unless you actually know what that acronym represents. But if you were given the name, Trusted Computer System Evaluation Criteria, kind of makes sense. We want to integrate computer systems into our Department of Defense environment. I need to have a way to evaluate those systems apply labels to those systems, like an A1 label or a B3 label, so that when I go and purchase that system or I'm going to integrate that system, I don't have to evaluate that system. It's already been evaluated by the Department of Defense or by a third party. I simply say, okay, I know that this system meets this criteria. The STIG or the requirements for this project say that it has to be at least a Division B or a Class B3, whatever. And we know that it meets that particular criteria because it was evaluated against the Orange Book. It was evaluated with TCSEC. Does that make sense? Hopefully that kind of makes sense. All right. Let's now talk about ITSEC, the Information Technology Security Evaluation Criteria. All right. ITSEC, also a structured set of criteria for evaluating the security of products, computer security systems, etc. Published in 1990 and was adopted by the French, by the Germans in the Netherlands and the United Kingdom, and was designed to work in those countries. And then there was a group of European communities, which includes 27 different members, called the European Commission, which is a part of the European Union, kind of adopted this as well. I don't remember when that happened specifically. But most European countries kind of widely accepted this evaluation criteria as the golden rule. Now, since then, ITSEC has been largely replaced with the one that we're going to talk about next, which is common criteria. Common criteria is another type of evaluation, an international standard for evaluation that we'll spend some time talking about in a little bit. And that's going to be, I'll hold off to get into that in a little bit here. All right. First of all, when it comes to ITSEC, we have kind of a set of terms that you need to understand. I am evaluating a system or a product. Let's say it's a firewall developed by Cisco. Cisco wants to sell their firewall, and they want to ensure to their customers that this firewall meets a certain level of security, right? Well, that firewall is called the target of evaluation. It's the one that's being evaluated and examined to make sure that its security features meet or exceed the specific testing criteria that we're applying in this ITSEC evaluation. The level of examination, the level of detail that you go into will provide different levels of confidence for the target itself. We call that the degree of examination. And there are multiple evaluation levels that are included in this process, E0 through E6. And we'll see those on the next slide or a couple slides a little bit later on. Obviously, as you go up in the levels of evaluation, you're going to have more extensive examinations. You're going to be testing the target more extensively. The evaluation is kind of more stringent and rigorous. We'll get into some of those that evaluation criteria in a little bit. All right. The criteria that we talked about previously, TCSEC, again, the U.S. Department of Defense, unlike that specification, ITSEC didn't actually require evaluated targets to contain specific features to achieve a certain certification level. So we might, for example, say that we want authentication or integrity features built into the platform, but you know, it may not, that platform may not provide confidentiality or availability. All right. In any regard, the security features that the target is representing, the security features that the target is claiming, go into what we call the security target document. And then the contents of that document have to be evaluated and approved. Now, the security target document is really what the vendor would provide. And then we would test against that security target document, verifying that the security features actually exist on the security target. All right. So let me kind of go through these bullet points here. I've just been kind of summarizing. A consumer or vendor defined a set of requirements from a menu of requirements into a security target document. The vendors then develop their products, which is the target of evaluation, and then they have them evaluated against that target. So the security target is essentially the goal of the system. Its features, its functions, and so on. All right? The target of evaluation is the platform that's being evaluated. The security target is an implementation-dependent statement of security needs for a specific target of evaluation. So this could be drafted by the product developer. It could be drafted by a consumer that it's looking for a system to meet specific criteria, and so on. The security target defines the boundaries and the specific details for the target of evaluation. And in the product evaluation process, according to the security target document that is provided by the vendor of the product. So generally speaking, it would be the vendor that's kind of establishing these baseline requirements. All right. We assign two levels, functional levels and assurance levels. And we'll talk about those levels in a little bit. ITSEC addresses a range of security needs, including integrity and availability requirements. And as I mentioned previously, ITSEC has largely been replaced by common criteria, which kind of is the same structure in the end. Okay. So what are the functional levels? Well, let's break them down. I mean, it's pretty, I don't know, pretty straightforward, I guess. There are 10 different functional levels, F1 to F10, and they describe the strength of the system that's being evaluated. These levels are provided for guidance only. Adherence to the specific functional levels is not a strict requirement, and consumers or vendors could define their own functional levels as well. Like I said, ITSEC is different from TCSEC in the assignment of the assurance levels. We'll detail these levels on the next slide. Ultimately, the goal here is to evaluate a system and apply a level of assurance to that system that can be trusted by the consumer of that particular system. All right? If that makes sense. We'll see. It'll make more sense as we move on to the 6 different levels of assurance later on. The assurance levels define different levels of confidence that the evaluator has that the product meets specific functional requirements, and it will continue to meet those requirements. In essence, it's the trustworthiness of the product itself. So here we go. E0 being least trusted, that's inadequate assurance. E6 meaning that we went through some formal process of evaluating, and all tools, all aspects of that system have been tested. Source code has been tested, functionality has been tested. We know that we're enforcing security functions and so on. I'm certainly not going to read all of these bullet points. You guys do not need to know all these bullet points. However, you do need to know that assurance levels apply to the ITSEC model, number one, and you need to know that the different assurance levels, what assurance level is associated to untrusted or inadequate assurance versus what provides the highest level of assurance. So E6, of course, would be the one that provides the highest level of assurance. That's what's important in this particular case. Okay? So the last component that we'll talk about here. So the next information or evaluation criteria that we're going to take a look at is common criteria. Technically, it's called Common Criteria for Information Technology and Security Evaluation, but we simply refer to it as Common Criteria. It is an ISO IEC standard, 15408 specifically, and just like we saw with ITSEC and TCSEC, it's specific to computer security certification. Common Criteria is a framework, just like the others, where we can evaluate systems, we can specify a system's security function, and provide some assurance on or assurance requirements for that particular system. The security functional component is called an SFR. We'll get into the definitions here in a little bit. And the assurance requirements are called the SARs. Just like we have a TOE with ITSEC, the target of evaluation, in common criteria, we call that the security target, or the ST. Okay? So again, I'm mentioning these particular terms because if they do have questions on the test, it's most likely going to be in relation to the structure of the framework itself, which includes understanding the terms and the acronyms that are used to define the framework's functionality. Okay? Common criteria, like I said, it is a framework, and again, it provides us the ability to specify computer systems security functional elements, the SFRs, or functional requirements, and the security assurance requirements, SARs, on a particular security target, which can then be taken from something called a protection profile. We can implement or at least state assurances about products based on those security attributes of those products, and then testing labs, independent testing labs, can then go ahead and evaluate those products to determine if they actually meet those claims. So in essence, what common criteria provides, it's at the very bottom of the page, is it provides assurance that the process of specification, the implementation and evaluation of a computer security product has been conducted in a rigorous and standard and repeatable manner at a level that is commensurate to the target environment for use. That's actually directly from the common criteria specification. So in the end, what are we talking about here? We are talking about literally asserting that a system meets specific security requirements and then using specific testing scenarios in a third party or in a laboratory environment to verify and assure or certify that those products meet those requirements. It could be an operating system, it could be access control systems, it could be a database, key management systems, any kind of technology that we're integrating into our environment. And by the way, this would be technology most likely related to security, right? Obviously, that would be necessary. Okay. So let me back up here a little bit, and I want to go to this bullet point because the protection profile is pretty important to understand. Like I said, it is a common criteria is a framework where computer systems Users can specify the security functional requirements and assurance requirements, and the security target. Those requirements can be taken from the protection profile. A protection profile gets created by a user, providing implementation, independent specifications, or information assurance security requirements with a combination of threats, security objectives, assumptions, security functional requirements, and security assurance requirements and rationales. Meaning that we are creating a document that specifies what the requirements are for a particular platform. We can then take that protection profile, look at the security functional requirements and the security assurance requirements, apply a test to the security target, and certify that security target against that protection profile. All right. So what are some of the definitions? This is kind of an important concept here. Common criteria evaluations are performed on systems or resources that we're trying to integrate into our enterprise, or potentially evaluating for integration into our enterprise. The target of evaluation, the TOE, is the product or the system that is the actual subject of the validation. Okay? And the evaluation is the purpose of that evaluation is to identify that whatever claims are made about that target can be verified. And that verification is done through these other elements that we're going to describe here, right? The protection profile, for example. A document that's typically created by the user or user community, which identifies the security requirements for the class of security device. Digital signatures would be an example, firewalls, any kind of technology that's specified for that particular purpose. All right. To expand on this a little bit, a product vendor can choose to implement products or design or implement products that comply with specific protection profiles. They can then, as they develop these products, they can then have those products evaluated against those protection profiles. So in essence, that protection profile is kind of like a template for the product's security target, and then the security target will allow us to identify that all the requirements in the protection profile appear in the security target's documents as well. So if I'm a customer and I'm looking for particular products, I can actually just say, you know what, I want to focus on the products that are certified against those individual protection profiles that meet my specific requirements in my environment. All right. The security target, that is not the computer or the firewall. The security target is a document. And that document is what identifies the security properties of the TOE, the target of evaluation. So we still use that same term to describe the component that we're evaluating. Obviously, the document makes claims to conformance based on protection profiles. And the target of evaluation gets evaluated against things like security functional requirements, and then we establish that security target for that particular product. This allows a manufacturer or a vendor to select specific evaluation criteria that will accurately match whatever capabilities or whatever the intended capabilities are of their particular product. So that means, for example, a firewall doesn't have to meet the requirements of an IDS or an IPS, or the example in this particular case, a database, right? The database requirements for a database management system requirements are going to be different than what we have for a firewall. So we will evaluate firewalls against security functional requirements that are specific to a firewall. We'll evaluate database management systems, or DMSs, against security functional requirements for a DMS. And then that security target is going to be published so that a potential consumer can determine whether or not that the specific security features that are claimed within that particular vendor's appliance or vendor's product actually have been certified by the evaluation process. Make sense? So what is a security functional requirement? This allows us to specify individual security functions which may be provided ultimately by the product. Common criteria does provide a catalog of functions, and the SFRs could state, for example, how a user acting in a particular role might be authenticated. That, again, functional requirements defines function, right? That list of SFRs that we published could vary from different evaluations depending on how the product is intended to be used and so on. Common criteria doesn't really prescribe any particular SFRs to be included inside the ST, but it does identify dependencies where operation of one function, right, access control limitation according to rules or roles would be dependent on another function, which would mean like the ability to actually identify an individual into a particular role. All right. This overall evaluation process also tries to establish confidence on the product. I mean, that's really ultimately the entire goal of this process. We establish quality assurance through two different methods. Security, I almost said that like Sean Connery, security assurance requirements, and evaluation assurance levels. Now, by definition, I'll read the definition that it has here and they'll kind of expand on it. Security assurance requirements are descriptions of measures taken during development and evaluation of a product to assure compliance with claimed security functions. As an example, an evaluation might require that the source code that's developed for a particular product is kept in some sort of change management system, or that somehow functional testing is performed. Common criteria does actually provide a catalog of SARs, and the requirements can obviously vary from product to product depending on what's being evaluated. The requirement that we have, this security, I keep saying it that way, I don't know why. Security assurance requirements for a particular target get documented in the security target document and the protection profile document. Now, finally, we have the EAL, the evaluation assurance level. A numerical rating, we'll see them on the next slide, but this is a numerical rating that describes what they say here as the depth and rigor of evaluation. Each EAL is going to correspond, in essence, to a package of security assurance requirements. And that's going to cover the development of the product, the implementation of the product, etc. And depending on the level of strictness, we'll apply a different EAL. There are 7 EAL levels. We'll see them on the next slide. EAL 1 is the most basic. It's the cheapest to implement and evaluate, but it also provides the least level of assurance. EAL 7 is the most stringent. It's going to require the most number of tests, and of course it's going to provide the highest level of assurance. Normally, whoever is authoring the ST or the PP, the protection profile or the security target, they're not going to select the assurance requirements individually. They're going to choose a package, and then that package is going to identify the requirements for the evaluation. Keep in mind, in this particular case, higher EALs don't actually assure or imply better security. All right, what do I mean by that? Well, it means that the claimed security assurance of the target of evaluation has been more extensively verified. Keep in mind, as a vendor, I'm making a claim that this device meets specific security or has specific security features or functionality or whatever you might want to call it. The level of evaluation assurance level, again, the terms themselves, as long as you can remember the acronyms themselves kind of give you an idea of what their purpose is. So just because I evaluate at level 1 doesn't mean that the device is less secure. It just means I went through fewer steps to verify that security target, or verify that that device meets a particular protection profile. All right. So most of the types of things that we're evaluating are going to be IT components like firewalls, operating systems, smart cards, and in the IT procurement process, we might apply supply chain vetting and vendor selection vetting based on common criteria. We haven't talked about other standards, but CC was basically developed through ITSEC, TCSEC. It kind of took the best components of those. We didn't talk about the CTC PEC, which is the Canadian version, but you know, it was kind of took the best of all of these different components of these different evaluation criteria. All right, so let's take a look at the EALs. The CEM, or Common Evaluation Methodology, provides that evaluation assurance level. The protection profile specifies the generic security evaluation criteria to substantiate the claim that a particular platform meets a particular set of standards. Right? We talked previously about what the protection profile represents. And we'll see the different assurance levels. We specified the evaluation assurance level, number 1 through 7. Again, that does not imply that 7 is more secure. It just means that we went through more rigorous steps to verify the protection profile against the target of evaluation. So in order for us to achieve a particular EAL, we have to meet specific requirements. You know, what are the design documents that were used to develop the platform? What kind of design analysis was done as we were developing the product? What functional testing was applied? What type of penetration testing was applied? Higher EALs are obviously going to result in kind of more detailed documentation, because we're going to have more tasks that we're performing, more functional tests that we're going to be performing. Let's see, the National Institute of Standards and Technology and the National Security Agency have agreed to cooperate on the development of validated U.S. government protection profiles, so that we can use common criteria to evaluate. Instead of TCSEC, Orange Book used common criteria to evaluate federal systems. Okay, so here are the evaluations. EAL1, functionally tested, lowest level of confidence that it meets the specific protection profile or the security target document. We tested the functionality. EAL2, structurally tested. Developers or users need a low to moderate level of independently guaranteed security, so kind of like low to medium. EAL3, methodically tested and checked, a moderate level of independently ensured security. EAL4, methodically designed, tested, and reviewed, moderate to high level of independently ensured security. EAL5, semi-formally designed and tested, requirement for a high level of independently ensured security. EAL6, semi-formally verified, designed, and tested, developing specialized target of evaluations for high-risk situations. And EAL7, formally verified, designed, and tested, provides the highest level of confidence. Now, obviously, I just read that to you, but at least gives you an idea of the levels of assurance that are applied. How this gets applied to the procurement process, to integration of systems into enterprises and whatnot, is specific to the organization. Obviously, it's going to be dependent upon what you are looking at within the organization itself. All right. Now, there are other industry standard guidelines for protecting private information or protecting personally identifiable information. The payment card industry data security standard would be an example of one that would apply specifically to the financial sector, or, well, specifically the payment card industry sector. But standards themselves are rarely sufficient for the security of a system. They represent the minimum mandatory requirements that we need to address to apply at least a moniker of security. But these are compartmentalized functions. Just because you might implement the recommendations of the PCI DSS standard doesn't mean necessarily that everything is guaranteed to be secure, because you still have human factors involved, collecting information, utilizing information, and so on. All right. So what is PCI DSS? This is kind of one of the common security standards that we see. We'll talk about it in more detail in a couple of slides here, but it is essentially the information security standards that we apply to handle credit cards and credit card schemas to process credit card information. ISO IEC 27001 and 002, we talked about these previously. The international standards for establishing security standards for business, public and private sector communication. The 27,000 series of standards are specific to information security practices, like best practice security implementations and so on. I would say it is not necessary for you to understand the specifics of any of these standards, but at least understand the family and how they apply to specific functions or specific components, right? So, for example, 27,000 addresses information security practices and best practice standards. 27001, 2013, Information Security Management Systems. That's its focus. We talked about this in one of our previous lessons, so I'm just going to kind of summarize what's on the slide here. ISMS defines governance structured for supporting information security programs. You know, the why, the what, the who, the how. What are the business drivers for security? Is it compliance requirements? Are they corporate values or ethical values? Are we concerned about privacy within the organization? Are we concerned about brand reputation? Well, they define brand and reputation separately. I guess that would make sense. And so on. That's the why. The what? The policies, the standards, the processes, the measures that we take in our organization. The who is the roles and responsibilities. And then we have the how, right? What are the specific procedures? What are the specifications? What are the implementation guidelines? Just a visual representation of this, standard or this framework. All right. So ISO 27001:2013 provides instructions to apply ISMS concepts to construct, run, sustain, advance information security management focused on 5 key areas. What are our general requirements? What is the management's responsibility? How do we audit? How do we review? And how do we improve? Essentially, a code of practice for information security management, which includes security control objective recommendations and standards and guidelines that allow us to decide what levels of control are appropriate to the organization, right? You know, how we apply that in our organization. Again, it's essentially a standard on how to manage information security. Ultimately, it's been around for quite some time. And like I said, we have kind of 3 stages of operation. I think I mentioned that from the certification standpoint previously. The stage 1 being the review of the ISMS, checking for the existence or the completeness of documentation. What is the organization's information security policy? What is their statement of applicability? What is their risk treatment plan? It's just kind of a way for auditors to essentially identify the organization and its culture you know, how the organization operates. Stage 2 is the actual compliance audit stage, independently testing the ISMS against the requirements that are specified in this document, right? In the framework. We need to make sure that we conform to the requirements, that the management system is designed and implemented and operating based on the requirements of 27001. And once that happens, you get certified. And then, of course, there's always going to be an ongoing follow-up review or follow-up audits to maintain that that you are you know, maintaining the standards and so on. And there are many different controls. I think I even kind of mentioned some of those controls previously. There are 14 focus areas. Number 1, information security policies, which provides kind of a formal and defined, a management guidance for support for information security, organization of information security, security mechanism in the organization that includes information processing facilities and information assets that are accessed or maintained by third parties. There are actually 7 different controls under that category. There's only 2 different controls under the information security policies. Human resources security, right? That one kind of makes sense. How do I hire employees? How do I handle employees leaving? How do I handle employees during their employment? There are actually 6 different controls under that focus area as well. Remember, there's 14 focus. Well, they really shouldn't be called focus areas here. They should be called groups. There's 35 different control categories that exist, 14 groups, and then individually 114 controls. I don't list all of them here, but if you go and download the specification, you'll see that. All right. Asset management. How do we prioritize and protect assets? Classify the assets, identify assets, apply the appropriate protection to the assets. That's a big section. There are 10 individual controls in that section. Access control, which has 14 individual controls, which includes limiting access to data, access control management, network services, unauthorized activity detection. We have cryptography. Surprisingly enough, only has 2 controls, but we need to protect confidentiality, integrity, and authenticity. The physical environment and or physical and environmental security, big one, right? We're talking about the building, the fences, the gates, the walls, etc. There's 15 set of controls there, but physical access, damage to physical property, interference with the physical operations, operational security, 14 controls there. Making sure that data processing, we're protecting communication, data in motion, data at rest. We have the supporting infrastructure for operational security. Comms security, making sure that data that's being exchanged between organizations is secure. 7 controls there. System acquisition, development and maintenance. Implements security controls into operations and development systems to ensure security of application systems, software, and data. 13 individual controls there. Supplier relationships, 5 controls there. That's supply chain management, basically. Information security incident management, 7 separate controls there. As you can see, we didn't list all of those specifically. Information security aspects of business continuity management, 4 controls there, and incident impact analysis and lessons learned and so on. And then finally compliance, meaning that policies, external requirements, laws, anything that drives policy, we're going to understand. 8 individual controls there. And then here's a pretty diagram that shows all of those elements. Okay. Now, that being said, these controls are there, to reflect changes in technology that would affect the organization. If we're implementing cloud computing as an example, these controls would apply. Okay. What about Cobit? Cobit is another framework, control objectives for information and related technology. Cobit is also a framework for IT management. You can actually go and get separate certifications with Cobit. We already talked about Cobit a little bit in one of our previous sections. The ISACA is the who actually created this framework in conjunction with IT governance. And we're focused primarily on defining generic processes for the management of IT systems. And in each process that we define gets defined together with process inputs and outputs. And we have specific process activities, various process objectives, performance measurements, and maturity models that we use to verify compliance with this particular framework. Okay. Typically, business and IT goals are linked together in some form, right? Especially when it comes to governance. There are 5 processes that get identified within this framework: evaluate, direct and monitor, align, plan and organize, build, acquire and implement, deliver, service and support, and finally monitor, evaluate, and assess. Now, do we need to go into those specifically? I don't think so. I don't. Let me see if does it go into it? Yeah, it kind of goes into it here. Yeah, we'll talk about that there, I guess. Oops. Going backwards. I need to go backwards. All right. What's the goal of this particular framework? Just like any other framework, it's designed to help companies formulate a plan to follow regulations, to follow law, to be more agile in adapting to changes in those regulations and law. And the most recent version of Cobit is Cobit version 5. There are 5 principles that drive control objectives, and they're categorized into 7 enablers. We'll see that on the next slide. In fact, let's take a look at that. So these are the 5 principles. These are the 7 enablers. So let's talk about the components. Framework. Okay. The framework allows us to organize our objectives, particularly our IT governance objectives, and good practices by different domains and different processes. And then we link them together to formulate our overall objectives. We also have process descriptions, which allows us to create common language, if you will, for everybody in the organization. And those process descriptions will map over to specific responsibilities in the management of this process, things that include things like planning, building, running, and monitoring. We have different control objectives, which allow us to provide a complete set of high-level requirements that we have to consider in order for us to have effective control of our IT process. We also have different management guidelines, which help us assign responsibility to individuals. We can agree on specific objectives. We can apply different measurement principles to measure performance and even illustrate interrelationships with other processes that might exist. And then we have maturity models, which help us address gaps in the design. So if you look at the 5 Cobit principles, they make sense. What are the stakeholders' needs? How do we cover the enterprise end to end? How do we apply a single integrated framework, which would, by the way, by definition, really be a holistic approach, where we're applying something that would apply to the whole environment. That's not what holistic means specifically, but kind of a summary. And we separate governance from management. And then on the bottom right here, we see the 7 enablers. The principles, policies, and frameworks will result in the different processes, the different organizational structures, will help define the culture, the ethical behavior of individuals within the organization. Of course, we're going to collect information that allows us feedback to all of this, because these are our resources. What are the services that we're running? What does our infrastructure look like? What do our applications look like? What kind of people do we have? What are their skills? What are their competencies? And that's why those are called resources, because they provide, the arrows are kind of in the wrong direction, but they provide input to this process. Okay. All right. Let's see. I think we only have one more topic here. My mouse go there. Oops. Let me get rid of that. The payment card industry data security standard. PCI DSS, we talk about this because they seem to like to ask questions about this quite a bit on the test. I suppose because transactionally it's something that everybody sees every single day in their life. But PCI DSS is, as I stated previously, an IS security standard that allows us to identify how we protect and handle credit card transactions, credit card schemes, and so on. And most major credit card companies mandate at least some sort of compliance with this standard. Now, it could result in maybe potentially lower fees for the credit card processing, or it could result in the ability to process or not process credit card information, depending on how how many credit card transactions the vendor is processing, and what the threatscape looks like for that particular vendor. Validity of compliance. Obviously, these are just going to be specifications that you have to meet certain criteria. That compliance is typically checked quarterly, or I suppose it could be annually. And it depends on the volume. Whether or not you meet compliance requirements will depend on the volume of transactions that you're handling. The reason why that is identified is because obviously the higher the volume of transactions, the more likely or more susceptible you are to an attack or to a breach, and the higher the impact that breach will have. So again, we're applying the principles of risk management to this concept. So if you're doing a small volume of transactions, you can do what's called a SAQ. That's what we did as a company. It's called a self-assessment questionnaire, and that will be verified. If you're doing moderate volumes, then you would do a QSA. So you'd have an external qualified security assessor come in and assess the compliance. That designation is applied by the Standards Council, and it would be just an individual that meets the requirements to perform the assessments. If you're doing large volumes and lots of transactions, you would have to issue a report on compliance, and most likely you're going to have some sort of internal security assessor that's specified by the firm. The internal security assessor would still have to be certified, but most likely is kind of a permanent resident, if you will. The standard, was spearheaded by all of the major credit card companies: Visa, MasterCard, American Express, Discover, and so on. Now, each of these companies kind of had their own independent verification process. Like Visa had the CISSP cardholder information security program. MasterCard had their own data protection program. American Express had their own data protection program. But, they wanted to come up with a kind of an industry standard. So in December of 2004, they drafted this standard, and it's been modified over the years. I think the last version was actually very recently, March of 2022. In fact, I think I got a notification of that. It doesn't change much, right? There's some multi-factor authentication stuff in there. But again, whether or not that would apply really depends on how many transactions you're processing. All right. There are six specific groups, or what we call control objectives, that apply to the PCI DSS standard. And we can see that listed here. Build and maintain a secure network system. Protect cardholder data. Maintain a vulnerability management program. Implement strong access control measures. Regularly monitor and test your networks. And then maintain an information security policy. Every version of PCI DSS was divided into these 6 different categories, but they also had a number of kind of sub-requirements. You can see the sub-requirements listed there. I'm not going to read all those. Most of them kind of make sense anyway. But you had different sections and so on. Ultimately, what you were responsible for was basic, common knowledge, right? Especially for information security. Installing and maintaining a firewall configuration that would protect cardholder data. The purpose of the firewall would be to scan the network traffic, block untrusted networks from accessing your PCI or your payment card systems, and so on. Modifying vendor-supplied defaults, passwords or security parameters for systems. Protecting stored cardholder data by using encryption and hashing, masking or truncating information, ultimately to just simply protect the cardholder's information. Encrypting the transmission of cardholder data over a public network using strong encryption mechanisms. Protecting systems against malware by applying antivirus software updates and malware applications. Developing and maintaining secure systems and applications. If you identify vulnerabilities in systems and applications, make sure that you fix those vulnerabilities so the baddies won't come in and gain privilege access and then exploit that privilege access to gain access to secure information. Restrict access to cardholder data to only the individuals that need that information. All right, we need to be able to restrict access to the cardholder data based on a need-to-know basis. Make sure we have identifying and authenticating access to system components. Each person needs to have their own access to the system components with a unique ID so that there is accountability in case an event occurs or fraud occurs. Restrict physical access to the cardholder's data if you happen to be storing that data physically. Track and monitor all access to the cardholder data. Make sure you have logging mechanisms in place that allow us to track user activities and if an investigation has to occur. And of course, test the security systems. Don't assume that the security systems are going to work. Test those security systems frequently so that you can identify weaknesses within that security system and vulnerabilities and so on. And then finally, the 12th one, maintain a policy on information security policy for all information security personnel. That policy needs to include awareness and understanding of the sensitivity of the data and what their responsibility is as the user of that information or even the custodian of that information to protect that data. Okay? All right.